All right. My name is Henry Schroer. I'm an atmospheric science major and a geography minor at the University of Kansas. Here is my project for my Geography 316 stats coding class, and my project is a simplified renewable energy siting analysis for wind turbines. So let's get into this. So I chose this topic and project based on my major, just how it relates to the weather and atmospheric conditions, on my interest in my jobs, so my job field interests and just how they kind of relate to this renewable energy and GIS. And also just as this is becoming much more relevant than ever due to climate change and how we need to kind of force ourselves to adopt a more sustainable energy consumption system. Um, and then also being in the state of Kansas and from the Midwest, this is interesting as, we live in a very, very promising spot for these kind of features and this kind of energy consumption and production. So it's cool to be relevant with your data, at least being able to see it in person. But at least going on to that um, should matter because um, this deals with the whole carbon issue of recent times and climate change. So being able to adapt these renewable energy aspects will be a huge help to further find a sustainable way to produce energy for everybody to use, as our lives are centered around this. So every step is important and everything counts. So as far as that, um, it's very important to find the best spots for these places to not waste time, not waste resources, and to get the best impact from what we're putting out there to help kind of accelerate this process of switching to a hybrid or all renewable kind of lifestyle. So typical data that's used for these kind of models are terrain, proximities to electrical grids, distance from residential areas, potential environmental impacts, reservation areas, wildlife, all that, and then accessibility and infrastructure for transportation. So besides all the atmospheric data used for these, which can go on for, it seems like infinity, there are so many different atmospheric parameters and things that can interact with what we're looking at here. So besides all that, the best would be what I'm looking at is the mean wind. It's very straightforward. But other than that, all these other ones I just listed are very more so catered to just society and how our efficiency can do this. If people want to see this in their area, just you get down to the political side of it. So there's a whole lot of planning that goes into this, as with any other kind of infrastructure construction kind of project. And I do think my method for this project is valid, as looking at the mean wind is the main kind of factor. As if you want to build a wind farm, you're going to want to find where the mean wind is and where the most wind is. So looking here, this is a previous kind of similar data set that I pulled up, but here's a very suitable land. You can see the Great Plains. Kansas is very nice for renewable energy, specifically wind. I want to note here that turbines are getting bigger in size because wind can get very strong at higher altitudes due to shear and other atmospheric parameters. But so I decided to do my data at 100 meters, which should be a bit different than the ones that are already kind of installed in Kansas, which are probably more so from 50 to 80 meters. So as time goes on, we'll see these get pretty big. My data, so my global, so my mean wind I got from the Global Wind Atlas. It's a raster data set. This data is very, very in-depth and a whole model on its own. So to fully explain it, you'd have to go read their website of all their methods and how they did it. But they do a lot of estimates of mesoscale modeling to help remove overlapping, ensuring high resolution, actually captures these characteristics that are influenced by certain topography and land use stuff. And this data is very much a higher resolution data set, as mean, there were millions of points that I kind of surfed through and cut down. So, and then other than my mean wind at 100 meters, I have my two overlaying vector layers, mainly my county's one that I will use for calculations, but the state bounty just for kind of a good visual representation of it. And all my layers are scaled at 1 to 200 million, which is not ideal, but it did work. So first I decided to grab my data and throw it into QGIS, which is a GIS platform, which I think is just very good and easy at doing these basic clipping functions. So I decided to use this to clip it to the state of Kansas. It was very handy and helped me save some time just because I'm so familiar with these. As far as my data manipulation goes and using R, it was very easy to upload my codes, or not my codes, my files, and easily to plot them just to make sure everything was working well. And as you can see here, they look very similar. And then, so for the main part of my methods for my final results, to find my max wind speed and max frequency of high values, I started with my first method of finding the max frequency of higher values that are equal to or greater than 8. This ended up not being the best, as it just wasn't that representative with all the raster points in each layer, as some had more, some had some zero values, so it just didn't really represent. And as when I'll show you the results, you can see that it kind of picked the wrong areas even visually. So other than that, here's my code for it and a filter that I use for the plotting. My second method was calculating the average wind speed for each country and to find the top 5 counties. So here, should have started here, but this makes a lot more sense to find just the most dense areas of these high average values, so which counties actually hold the highest wind speeds at average. So then same thing, I did some filtering, which all was pretty straightforward and not too bad. And then, so for some easy results, I had to convert these to a data frame, which is just to make sure all these statistics and plotting go much smoother. So here, really need to just focus on my mean value here. So my mean for the whole state of Kansas of this wind speed is 8.16 meters per second. All these other ones aren't too relevant here, so I won't go into too much detail. And then it was pretty easy to get this summary though. And then here are some basic plots. I had a regression box plot, and what I want to look at is this histogram with my distribution, as this is a pretty normally even distribution for the mean of the mean wind in meters per second of my raster data set. And just looking at this and seeing how the data cut down from having areas from like 2 meters per second to up to like 10, that Kansas from being from 6 to 9 is a very suitable area for the installation of wind turbines, and for many reasons. But just looking at this data here, it's pretty obvious that this will be a suitable and good location overall. So can't really go much wrong with the state of Kansas for wind turbines. So here are my main findings and my main models and plots. So here was my first one that didn't really go so well with my high frequency of wind speeds. So you can see, you'd expect everything to be here, but I was getting areas here, a bit outward, as you can just, even visually, you can just tell these aren't as high. So that was just, these are bigger areas, so they hold more pixels, so they're gonna maybe end up averaging out to more areas like this. And then, so you get some random counties, but they're all still relatively good. And then for my highest average wind speed, my top counties are much more of what I expected. So a little outlier here, which I wasn't too sure of. Expect something here more, but either way, this looks a lot better. And these, the number one is Butler for both, but you can see following these other counties that this one is much more representative of counties that actually hold more mean wind. So going on, some supporting context. this is from 2014, but some of these other operational and proposed wind turbine farms, you can see some already in our area. So what if there's any new plots out there that can show this? And then here's a future model of future wind speeds and wind power, and you can see Kansas is good in all these models and all these certain data sets. So a little bit of supporting context to help solidify that these areas in Kansas are very probable. And so overall, Kansas is a very ideal location for future installation of wind farms, and the counties that can be heavily considered are Butler, Chase, Morris, Kiowa, and Cowley, since they all hold high averages of mean wind at 100 meters above the surface. And as far as future research goes, looking at correlations with elevation is pretty huge as far as wind goes. As you can even see from this elevation map, it's pretty similar to what we're looking at here with especially this area. You can see just the topological features of this do help force for stronger winds right here, which kind of brings it into looking at, you can do endless research with other meteorological and atmospheric science aspects. So, I mean, off the top of my head, looking at topological flows like slope winds, gap flow, valley breeze, just big wind scale dynamics, and then, I mean, endless other variables like pressure, wind shear, temperature, surrounding geography, above upper atmospheric conditions and below it. So you can definitely do a lot with this. And other than that, I hope you learned something in that it is fairly easy to diagnose areas, but the nitty gritty of it, you'd want to really add in a lot of variables for a huge multivariable model, comparing all these things and seeing which area is actually the best. So that would take definitely future research opportunity to do, but hopefully people are working on that. And other than that, thank you for listening and watching. I want to thank specifically that Global Wind Atlas for producing such a good data set. And it doesn't get much better than that, and highly recommend going and looking that out. But other than that, thank you for watching and listening, and that's it.